equation of the tangent. Let's say I have a circle with 2 points P and Q, and I draw a line through P and Q. What I get is a line which forms a chord. Now I bring the point Q closer to the P. So let's say P I keep it where it is and Q I bring closer. Now as I bring closer and closer to P, what will happen is, now here, so P, a point on a circle, Q, a point close to P. Now as we move the point Q closer and closer to the point P, that is, we say Q tends to P, and there's a notation for that. Q moves towards P, the limiting position. Limiting position means when Q becomes equal to P. The limiting position of the chord PQ is called the tangent to the circle at. That is one way of looking at it. Now another way of looking at it is, let's say these are the 3 circles with these centers. I want to have a line. So the possibilities are that the line goes outside, goes through inside, and just touches the circle. So let's say this is A, this is B, and this is C. Now if we draw a perpendicular from the line to the center, so these are perpendiculars. These are the only 3 possibilities. When a line touches the circle at only one point, it is called the tangent to the circle at that point. So in a way, the perpendicular distance between the line and the center of the circle, when it is equal to the radius, which is what is shown in C, then we call that line as the tangent. In both the other cases, either it is greater or it is lesser. So now let's try to figure out the equation. Right? Let's figure out the equation. Okay, and this is the center, this is the tangent. Remember, this is perpendicular. Now we know the equation of the circle is x square plus y square plus 2xy plus 2fy plus c equal to 0. And we know in this the center is, let's say this is C. So center C is at minus g comma minus f. Now let us say we have a arbitrary point on the circle. So P x comma y, an arbitrary point on the circle. Now PT, so let's say this T, PT is the tangent, and we know PT is perpendicular to CP. Okay, now slope of PT is going to be what? Slope of PT is going to be minus 1 by slope of, or we can just say the product of the slopes of PT and CP is equal to minus 1. Or we can say slope of PT is the negative reciprocal of slope of CP. because they are perpendicular to each other. And so now let's see, slope of CP is equal to what? This would be, by the way, this is x1 y1. Okay, so y1 minus f by x1 minus g. Okay, f and g are minus n minus g are the center coordinates of the center. So this can be written as y1 plus f by x1 plus g. Okay, we have got the slope of CP. Now let's substitute this in slope of PT equal to minus 1 by y1 plus f by x1 plus g, which is minus x1 plus g by y1 plus f. Let's say slope of PT is m. M is equal to minus x1 plus g by y1 plus f. Okay. Now, equation of the line which is the tangent PT is y minus y1, equation of the line, is equal to slope times x minus x1, where x comma y is an arbitrary point on the tangent line. So now y minus y1 is equal to, now what is the slope, is equal to m. M is, we found this, minus x1 plus g minus x1 plus g divided by y1 plus f times x minus x1. Let's take the denominator to the other side. Y minus y1 times y1 plus f is equal to minus x1 plus g times x minus x1. Now here let's expand it off. y1 plus fy minus y1 square minus fy1 is equal to minus x1 square minus, no, not x1 square, minus x1 plus x1 square minus gx plus gx1. Let's rearrange this and let's multiply both the sides by, now let's shuffle them around. Okay, so the idea is to get the equation of a circle. So let's bring in here y1 square, let's take it to the other side, and the negative ones, let's bring it to this side. Minus becomes plus x1 plus y1 plus fy, and then minus g becomes plus, is equal to x1 square plus y1 square plus gx1 plus fy1. Okay, so we got this in this form. Now let's try to figure out. Here we have gx1 and fy1, x1 square, y1 square. So looks very close to a circle, right? Equation of the circle. The only thing missing is this should be 2gx1, 2fy1, and c is missing. So let's do one thing, let's add. gx1 plus fy1 plus c. So which means on this side also we have to do the same thing, plus gx1 plus fy1 plus c. So when we do that, what happens? Let's take out common. So this becomes x1 plus y1 plus gx plus x1 plus fy plus y1 plus c is equal to, now on this side it becomes a circle, the equation of circle. So this would be equal to 0, right? So this would be 0, this is plus, so equal to 0. So this is the equation of a tangent at x1 y1. Let's try to figure out the condition for a line y is equal to mx plus c to be a tangent to a circle at origin. So that is x square plus y square is equal to a square. So remember, mx plus c, this is the equation of the line, and x square plus y square equal to a square is the equation of the circle at origin. A point which is common to both means what? We have to combine these equations. So let's combine them. X square plus, now we do the substitution, mx plus c square is equal to a square. Let's open it up. M square x square plus 2mxc plus c square is equal to a square. So 1 plus m square x square plus 2mxc plus c square minus a square equal to 0. Now this is a quadratic equation in x. Now the line will be a tangent if it touches the circle at only one point, right? That means the roots are coincident. That means there is only one solution to this equation, quadratic equation. Then only it would be it will be touching the circle only at one point, and hence it would be a tangent. So b square minus 4ac equal to 0. So let's see. B is 2mc. So 2mc square minus 4. A is 1 plus m square. And c is c square minus a square equal to 0. Let's simplify this. 4mc square, m square c square minus, now 4 is common, so if we take it out and take it to the other side, it will become 0. Okay, now let's expand this. C square minus a square plus m square c square minus m square a square equal to 0. M square c square minus c square plus a square minus m square c square plus m square a square equal to 0. Now this and this gets cancelled, and we are left with a square minus c square plus m square a square equal to 0. Now here let's take the negative to the other side. A square is common. 1 plus m square. 1 plus m square equal to c square. Or in other way, we can write it as, we can write this as c square is equal to a square 1 plus m square. Now this is the condition that has to be true for that line to be a tangent. Mx plus c to be a tangent to the circle at origin. Okay, I think that's enough for today. Bye.